I'm Scott Moore, and I'm a performance engineer. I help to make software and applications faster, better, more resilient. Lately, there's one thing on my mind.
Where's the best barbecue at, man?
So I'm going across the country, talking about performance engineering and barbecue. Join me as we take the performance tour. Hey, this is Scott Moore, and we are on the performance tour, and we are talking about browser level performance testing and why that's different. And the best person to talk to about that is Tim Koopmans. Tim, why don't you share who you are and what you do?
G'day, my name is Tim Koopmans. I'm the founder of Flood.io, which is a distributed load testing platform, cloud-based, and we support mainly open source tools for the generation of load. Flood Element is one of those tools. But actually, before we go on, you said performance testing, and I say load testing. Mm-hmm. Are they the same thing?
I don't think so. Yeah. I think load testing is an element of performance testing, just like performance testing is an element of performance engineering. So there's lots of load tests, stress test, volume tests, soak tests.
I agree. I think that load testing is traditionally like a style, like one of the types of performance tests that you might run, but I've been going with load testing lately just because it's less characters and
most people know what that is.
And I think also like performance is like a trait. You know what I mean? It's a characteristic that you're trying to establish or measure or observe. So that's why I sort of favoured load testing, but I like to use it interchangeably. I think it's good to know.
Here's the danger of going with just saying load testing instead of that. A lot of initial meetings that I have, people say, I want you to stress test our system. And I say, well, I can do that in 15 minutes, but it may not be very valuable to you. So when I say load testing, they go, well, what's the difference between load and stress? I'm glad you asked the question. I want to create the real world scenario, worst case condition, but what would actually happen versus stress, which is unreal. So that's why I keep saying performance testing, because it's, okay, what type of performance are we looking for? Do you want me to break this piece, or do you really want to find out what it's like for your worst nightmare to happen in reality? There you go. So.
Well, I think we're both right.
Okay.
Maybe we can A/B test that.
But he knows he's wrong. He knows he's wrong. It's my show. Okay. So let's talk about Flood, and let's talk about browser level performance or load testing, because you've come out with this blue virtual user.
Now you've put me on the spot. It is the browser level user. Because I thought blue sounded pretty cool. It is cool. As something memorable. But in my mind, there's two styles of sort of like simulating load. Traditionally, we would do things at the network level, the protocol level. So I just refer to those commonly as protocol level load testing tools. So that would be things like JMeter, Gatling are the ones that we support. But of course, there's many alternatives out there. And I think historically, that's where a lot of load testing tools have started. I'm not sure of the reason why. I think if you look at the history of load testing or performance testing and go all the way back, say 20 years ago, it just made sense to do things at the protocol level, like early days of the internet, even thinking about how to automate something, it just wasn't really practical to go and spin up lots of processes. So protocol level was something that you could do in a thread, let's say.
We also didn't have such heavy pages where people were doing stuff browsers were never meant to do.
Yeah. Like, so if you go back 20 years, and I've said this in some of my presentations, look at a common web page, it might make, 15, 20 requests, let's say, like the Google homepage, if you look at that. Or I like to use the Amazon site, for example. But if you go to, say, Amazon now, it makes over 300 requests at the protocol level.
Sure.
And, the performance test experts could say, well, yeah, a lot of that's kind of, static and doesn't matter as much, or it's easy to be picked up by a recorder. And, it's pretty simple to sort of filter out the sort of, all the noise and just focus on the sort of transactional things. But yeah, the reality is over time, anything in a browser is kind of like ramped up in terms of complexity, and there's tons of things, like we had JavaScript came out and XHRs and sessions and cookies and security related features. There's a whole bunch of sort of heavy lifting that the browser does for us under the hood. And if you were, say, new to performance testing and just coming in blind from the outside and never looked beneath the hood before, you had no idea about what's happening beneath the browser, you might be sort of fooled into thinking, hey, this should be pretty easy, right? Like I just have to simulate 5 requests, and then I can do, that's my login, search for a ticket, buy a ticket, and check out. And it's like four or five things that I've got to simulate, right? That's the trap.
It's never like that anymore. And in my opinion, though, anything that gets you closer to what the end user actually does and what you see from their perspective, the better off you're going to be. So if browser level gets you there and you're not missing those gaps that you would from a network protocol level, all for it. But it does consume more resources, obviously. That's the trade-off, right?
Takes heaps of resources. I mean, it's funny because the history of Flood, when I first put Flood together in 2013 or whenever it was, my focus back then wasn't about making it easier for myself to script. I could already write JMeter scripts and load runner scripts till the cows came home, you know what I mean? What I was looking for back then was, the problems I was trying to solve was how do I do this in a distributed sense? How do I run lots of copies of these scripts? That was the first problem that I had to solve. So that's sort of the execution layer. And then the other problem that I had to solve was reporting, and we can talk about that another time, but how do you bring all the results together and then make sense of the results and do the analysis? So I was kind of focused on those for many years, and Flood naturally was also focused on that. I think we've done a really good job in those two areas, especially with execution. We've kind of solved for, how do you run 1,000 load generators on the cloud? So I guess over the last couple of years, we started to think, hey, we're doing the execution piece really well, but customers are still struggling, especially customers that have no performance background, and we get everyone coming to use Flood really. They're still struggling, putting together that first script.
Right.
They open up the JMeter UI and they're freaked out.
Right.
Or, maybe they've never done any programming before, or maybe they've got some test automation background, but they have really no idea how to get started. And so that's when the wheels were sort of turning about, I guess, looking for some better way of doing it in the browser. I should say that we've supported Selenium for some time, but Selenium was never really made with performance testing in mind.
Not originally, right?
Yeah, not originally. Right. So when Puppeteer came out, which I forget the dates. We'll have to fact check.
Right.
But it came out some time ago. Ivan and Ivan's the other co-founder. We were really excited because we were like, wow, this is we did some small tests. We got some Puppeteer running in a container with Chrome, and it was super easy to automate. And then we started to think, well, what happens if we just sort of exposed that, but put a performance testing or a load testing bent on it, so that we could run it on Flood, and that's how Flood Element was born. Because it's really just a wrapper around Puppeteer.
Amazing. I kind of had that suspicion. I didn't know that, but now that I do. Okay, so we talked a lot about testing, but there's the other side of the fence, which is the monitoring. Traditionally, you've had APM, application performance monitoring tools, but now we've got this new term called observability. What's your thoughts around that and where we go over the next few years when we talk about performance monitoring?
Yeah, that's a really big topic.
You have 1 minute. No, just kidding.
So I think if we've solved for, say, load test creation, we know how to make tests, and we're making it more simple for customers to create tests, and we've solved for execution. People can run lots of stuff everywhere. The last piece is the pointy end of the spear is the analysis. There's no point having these amazing scripts and amazing distributed execution environments if you can't actually solve performance problems.
Right.
I'm not saying that every test effort is about identifying and fixing performance problems, but it's a really nice outcome if you're spending the money to actually go and improve performance. And that can be for a whole bunch of reasons. That might be, we don't need to talk about it because everyone knows on this show, right? But whether it's capacity or fine-tuning things, that's where the meat and potatoes are really, isn't it? That's what we want to do. So
But 5 years from now, I mean, what are we looking at for the next? Where do you see it going?
I think from an APM space, it's really large and it's really well populated by some great players. You know, there's Dynatrace, App Dynamics, New Relic. At Flood, we use Datadog a lot, for example. So there's so many APM tools, and that part of the market is really covered quite well. But it's still very distanced from traditional load testing, if you know what I mean.
Those groups still need to really connect and integrate together.
Exactly.
Do you see DevOps doing that?
I think DevOps forces that. I mean, we were talking earlier over a coffee about, I think the story is coming from production more than it was, everyone's talking about shift left. I mean, shift left sort of helps you save face earlier, but I think the real story is what's happening in production, you know what I mean? So, because ultimately that's where you have your real users, that's where you're losing money if things aren't working, right? So
where you're doing triage, right?
So yeah, I mean, looking at the tools in that space, like APM tools, in my mind, well, when I used them some time ago, it always started off with you either had it in production, and maybe you had it in pre-production, and it was like never both, you know what I mean? Or you could only have it in that environment and not the other environment. It was a complete waste of time, because like if you can't see what you're doing in, say, a pre-production environment, or if you can't test the same thing in a production environment, you can't measure it, you can't observe it, then what's the point of doing the test?
Absolutely. One of the next things we want to do here is, instead of just talking to Tim, because he's going to tell how wonderful Flood is, let's actually talk to one of their customers that uses Flood, how they use it, and the benefits that they're getting out of it. How about that?
Sounds great.
So I'm on the line with some people from Braze, some very smart engineers. Why don't you guys introduce yourself?
All right, I'll go first. So I'm Zach McCormick. I'm an engineering manager here at Braze.
And my name is Matt DeCipio. I'm a senior site reliability engineer here at Braze.
Awesome. So I would say, from just knowing Zach and knowing what you guys do at a high level, this is probably the most cutting edge company that I've talked to with regards to performance and getting into the depth of testing APIs, testing the stuff that you guys do. But it's interesting because I recently interviewed Tim Koopmans, who is the founder of Flood, and I know that you guys use Flood. So I want to talk about that just a little bit in this interview. So first of all, Zach, why don't you tell me a little bit about why performance is so important to Braze and what you're doing there?
Sure, absolutely. So for those that don't know, Braze is a marketing automation software as a service company. So that means that we've got some pretty big brands that we provide services for, almost as infrastructure as a service. And so these companies, these are going to be people like Lyft or Seamless/Grubhub, Stiddy, Microsoft. They use our platform to send out all their sort of marketing automation messages. That could be email, push, in-app messages, SMS, sort of all kinds of things like that. And the number of messages that we're sending per day, we're generally pushing out something around 3 billion messages every single day.
Wow.
And we have customers all over the globe. And so obviously performance is something we're very cognizant of. And uptime is something that we're also extremely cognizant of, because when you're operating with these types of customers and you're operating at this scale, you can't afford to be down for a minute.
So tell me a little bit about what's your process for performance testing, sort of at a high level?
Yeah, absolutely. So our platform has, we've got multiple environments, right? So we have different customer clusters, different sort of regions that we have infrastructure deployed in. And then we also have staging environments. So in one of those staging environments, we run a series of integration tests multiple times a day. Those are things that are testing sort of the functional, like behavioral goodness, so to speak, of our platform. On top of that, as we release new features and as we make changes to existing features, we do a variety of things to determine whether or not we're going to see performance regressions, or if we're going to see any changes in sort of the underlying behavior of that functionality. So, for instance, did a new addition to our software add an additional database query somewhere, or are we hitting some API endpoint that we weren't hitting before? Otherwise, sort of finding these things where we're introducing performance concerns or introducing new bottlenecks.
And is all this I'm sorry, is all this built into a CI/CD pipeline where it's like it's all automated and you completely shifted left and you just get output?
Yeah, so we're getting to that point. So right now we do a lot of manual testing, and so to be able to do that sort of manual testing, we need to have tools that are built for that sort of thing. And so that's where Flood.io comes in. I've actually got a blog post on Braze's blog where I demonstrated sort of how I use that to test out an example of some functionality we have called connected content, where our customers will they'll hit their own APIs in the generation of a message. And I really enjoyed using that tool, and so now it's one of the main tools in my arsenal for running this sort of load testing against our APIs.
Matt, what are you doing on the team?
Right now I'm building out a transactional API. We want to be able to offer a transactional product that meets certain SLA requirements.
And so I think understanding what Braze does, you're the guys who are going to make sure that my barbecue is delivered on time. Is that right?
Absolutely. We don't want it to be late. That's
With something like this, with sending messages, the whole thing is this big distributed system with lots of parts that are being coordinated, in various places. And Datadog's proven to be like an extremely good tool in terms of seeing what's happening at every single point, as well as with their sort of distributed tracing technology that they've got integrated. We can see how all the pieces even fit together, and we can see it sort of in one view, which has been very good for us with testing this sort of thing, because you can imagine as we're sending these messages out, there's going to be sort of multiple pieces to it. And when we kind of combine that with Flood.io and our sort of load testing scenarios that we create, we can see how each individual sort of service in our architecture is reacting to the different requirements that we're putting on the system with this type of load. So we can see things like, are we overloading a database? Do we have the CPI or the disk usage getting too hot on a particular database? Or are we seeing the cache hits or cache misses, the behavior that we would expect for this sort of thing? We can also test something which I think is like under-tested, at least maybe in some places that I've helped out with this before, is in things like error handling. So when you provide like invalid data, is the server going to be able to handle a lot of load of invalid data?
Right.
Of course, a lot of people always test the happy path and make sure that works, but maybe your system is at risk of a denial of service if you send it a bunch of bad data, and that's something that we want to prevent as well.
Well, I'm really excited about what you are doing there, and I can't wait for the rest of the world to see this. And if anybody has any questions or they want to reach out to you guys later on, how can they reach you?
Yeah, reaching us via email is probably the easiest thing to do. So I'm just Zach, Z-A-C-H, at Braze.com. Pretty simple.
Cool.
I am Matthew.DiCipio at Braze.com. DiCipio is D-I-S-I-P-I-O.
Got it. All right, well, I'll be sharing that, and thanks so much for being on this episode of the Performance Tour.
Let's just dive into it. We've done a couple tests of this already, so we'll skip some of the setup. But diving in here, you've got streams, which are sort of the setup where you figure out what your test looks like. Your floods, which are going to be instances of actually running it and looking at the statistics. And then grids here at the top, which we can skip because we don't have to build anything custom. But that's where you'd set up exactly sort of what the load looks like. We're just going to go with sort of a generic concurrent users that they have set up with us. It actually works pretty well. So hopping right into it, we're going to use our staging instance. And we're going to hop right into our staging instance in the EU. And we're going to ping our health check. That's the first thing we're going to do. Just make sure that we have enough servers online that the most simplest of simple endpoints will respond properly. So if you look, we have this URL, health check 2. I don't believe we have any headers in this. Nope, nothing in this. We'll go ahead and click verify, and we'll see that we get a 200 OK back. And if we look at the body, we get the word online, which is what it's supposed to do. And if we look at the headers, everything pretty much makes sense here. It looks like we're seeing Nginx, which is correct. We're seeing via Varnish, which is also correct. We use Fastly as our edge network. So everything checks out so far. So next we'll click Configure Launch. And this is where we'll set up our flood. And so like I said, this is an instance of this test. And so we're going to use on demand, so using Flood's infrastructure. because we're testing our EU staging, we're going to hit it from the EU Central Frankfurt data center, which I believe would be the same AWS data center that we're using. We'll use 500 users per minute, or 500 users rather, and we'll do a 5-minute test with no ramp up. We should already have enough servers online to not have to deal with ramp up. So that all said, let's launch the test. All right, we've loaded this page. Now we can see that our flood is running. We have this nice little loading icon in the corner to let us know. It tells us when it turned on, and we can start to see a few data points roll in. There we go. We can see the transaction rate going up. We can see our concurrency stays the same. We didn't specify any ramp up time, so that orange line is just going to be horizontal. And then we can see our response time started out a little bit slow. That's probably the cache warming up a little bit, and then our response time started to level out at about 20 milliseconds, which is pretty good. So considering our health check endpoint is more than just a web server health check, it actually hits a database and it hits a variety of other services. In this particular example, the idea is to make sure that this entire part of our system is online. So around 15-20 milliseconds is actually pretty solid. So if you go to streams, so the health check that we just tested, that's nothing new. But the next one that we're going to look at, this is our transactional sending API that we've been working on, and we want to use flood.io to confirm that it can basically withstand the load that we expect our customers to be putting on it. So we're looking at actually having SLA associated with this endpoint, and we want to make sure that we're very comfortable inside of that SLA. So if we go ahead and dive in, we'll see that the URL looks a little bit different. It's not going to be just health check this time. You can see this is currently our V1 of this API in terms of this URL is probably going to change, but this is what it looks like right now. We're going to throw a couple different headers onto here. So our authorization header, so you can see there's an API key in there, and don't worry, this won't be here when the video is published, or won't be active anymore. And you can see that we're going to be sending our campaign number 13. We're just going to go ahead and send that. Our staging does not have that many campaigns on it. So if you dive in, you can see in our body here, Matt made this example up. So our username that we're going to be sending to is Matt, and the recipient that we're going to be sending it to is going to have a user alias of dummy. So the cool thing is all it does is just validate that these arguments are good, and then it enqueues a job to send up a transactional message. So these will go straight to Matt's dummy inbox, so he can see as we send several thousand of these. But real quick, we'll do our verification. So we can see if we send a single request, we're going to get a 201 created. And if we look at the response, we're going to see that send ID, which is what our customers would reference if they want to look up the status of the send, or if they set up like a webhook post back system, what they could, some identifier for this message. And you can see that the status is pending. So nothing crazy out of the ordinary here. So let's go ahead and launch it. So we'll click configure launch. We'll hop in, and we're going to do pretty much the same thing as we did last time. 500 users, our EU central region. We'll do it for 5 minutes, and we won't do any ramp up. So let's go ahead and launch our test. If we pop back in here, it looks like our test finished. And we can see that we pretty much had a very similar response time curve as we did for our health check, which is great considering, again, this should be hitting pretty explicitly just a cache. It only hits the database in the first few hits. Even if there are a lot of them that are happening in parallel, you only end up with database transactions in the first maybe 50 requests before the cache is populated across the system. So all in all, this is exactly what we would expect to see. And between flood.io and Datadog and all the unit testing and integration testing that goes in with this, I feel extremely confident that our transactional messaging API will be able to handle pretty much anything we throw at it.
Okay, here we are about 3 hours into this. We're still holding steady, perfect temperature, and we can see our meat is actually in the place that I've got the temperature gauge has actually reached 161 degrees. It's okay for it to go a little bit beyond that. 165 is fine. We're holding the right temperature. This is what the ribs look like at this phase. So as you can see, it's starting to look really good. This is when the fun really starts to